Okay, so solving nonlinear inequalities. Now, like we said up here at the very top, right, when solving nonlinear inequalities, right, so these nonlinear ones, you need to use a sign line. All right, and that's because when we're solving like something that's a quadratic here, x squared minus 4, we know that we have a parabola, and we are going to have these roots here at 2, 0, and negative 2, 0. And we get to clearly say x is equal to 2, or x is equal to negative 2. It's pretty straightforward when we're solving. But now when we have an inequality, and we've gone over this a few times, which is, again, we're going to have this quadratic here, and my parabolas are not popping, not auto-generating here. So our parabola, and what we're going to do is make sure that we are looking for everything that is above our line here, right? So we're things that are greater than 0. So all of this region up here is what we're looking for. So if we kind of think about it, we have all the possibilities of everything from negative infinity to negative 2 and from 2 to infinity. So our answer from this one is negative infinity to negative 2, union 2 to infinity, right? Those are all the possibilities that would give us outputs that are greater than 0. So that's with the quadratic, and we've kind of looked at those. But now when we have these polynomials, and we're going to go ahead and graph them, we first, of course, need to find our zeros. So this is in our factored form. If need be, you would want to factor first. You can always kind of put a note there. Factor first. All right, so our zeros here are that x is equal to 2/3, x is equal to negative 1/2, and x is equal to negative 2. So I'm going to go ahead and I'm going to put all those zeros on this line here. So we have negative 2, negative 1/2, and it doesn't really matter how they're spaced, because the idea is, hey, you're just saying, are those going to be positive or negative? And what I'm going to do is actually kind of draw this polynomial out. So if I'm thinking about it in terms of end behavior, right? If we're thinking about it in terms of end behavior, we have, let's see, where's my pointer? Need a pointer here. There we go. We have a negative x, positive, positive. So our end behavior is going to kind of come down and up and down this way, right? That's what our end behavior kind of looks like. So just kind of taking my highlighter here, and quickly I'm just going to kind of sketch through this. You don't have to sketch this every single time, but I know that it's going to kind of look like this. And what this does is it gives me an idea where things are positive and negative, right? It's going to be negative down here. Actually, I'm just going to put this. It's going to be negative here. It's going to be negative here. And then I also know that it's going to be positive here and positive here. So then I have to ask myself, well, I'm looking for it to be less than 0, aka I'm looking for the negative sections of it. So my answer to this is going to be parentheses, because I'm also not equal to, so negative 2, negative 1/2, union 2/3, infinity. All right, so again, you're kind of drawing the sign, you're using what you have for your polynomials, and where it's being positive and where it's being negative. So we can go ahead and try these. In class, I'd have you try them on your own, but let's just kind of see here. So again, we're finding our zeros, so find zeros. So I can't factor this. There's no factors of 12 that add to 2. I'm just going to set up x squared plus 2x plus 12 equals 0 to find my zeros. I'm going to choose completing the square is equal to negative 12. I'm adding 1, and we have x plus 1 squared is equal to negative 11. Take the square root, and we have x plus 1 is equal to plus or minus I root 11, meaning x is equal to negative 1 plus or minus I root 11. All right, so this means, of course, in here is that we have no real solutions. We have an imaginary solutions, no real solutions. So if I'm thinking about values where x is going to be less than 0, right? So I'm going to be this less than 0. It's not going to happen. Now, if it was greater than 0, it would be all solutions because it would be above. So what's going on is that this is above the x-axis. If we kind of graph this here for a second, right? We're going to be here, a little set of axes, and we know that this parabola is going to be above the x-axis here, right? We're going to be over here. So we have no real solutions, meaning that there's no solution for this. So answer for this is no solution, because we're never going to be less than 0. And then on this next one, this can be factored. This is going to be x minus 5 squared, and it's going to be greater than 0, meaning that my roots are going to be x is equal to 5 with a multiplicity of 2. So if I'm kind of thinking about my number line here, I have 5, and again, it's just going to we're thinking about this parabola here, it's just going to go ahead, it's going to come down and be kind of bouncing off that 5. So if I have my plus or minus signs, I know it's going to be positive here, it's going to be positive here, it's going to be 0 right there. So I'm looking for when it's going to be greater than 0. Now, if it was greater than or equal to, it would be all real numbers, but it's going to go ahead, it's going to be from negative infinity to 5 union 5 to infinity, because at 5 it equals 0, and we want when it's going to be greater than 0. All right, so with these polynomials, right, you are able to have sign changes only at your real zeros, right? So a polynomial function, it's only going to change at those real zeros. So what we mean by that is that if we just sketch a polynomial right here, we are going to, no matter what your polynomial looks like, right, it's changing from plus or minus at these zeros that we have right here. But if we have a, if we have a rational function, then we can go ahead and have a few different things, right? So for instance, I have a rational function, I have some asymptotes here, right, our asymptotes, and then we end up having this rational function where we come up this way, and then we come down again, go up this way, and then we come this way. So as you can see here, it also changes at these vertical asymptotes. So we have a sign change here, we have a sign change here, and we also have a sign change there. So just be careful that with those rational functions, we also want to make sure that we're looking for these vertical asymptotes. So let's go ahead and solve for a few of these. So again, we're saying when solving a rational, let's get a color here, when solving a rational inequality, you must include the real zeros of the function as well as the vertical asymptotes on the sign line that we're going to create. So looking at this one, let's first go ahead and separate it out here. We know that we're going to have, we're going to have zeros, or we're going to have a real zero at x is equal to -3. And if you're wondering where I got that, I know that when this is 0, it's going to go ahead and give me -3. Sorry, when that's -3, it's going to give me a 0. And then my asymptotes are going to be at x is equal to 1, and then also x is equal to -1. And again, I got that from this position right down here. So now let's go ahead and draw our sign line. line here. All right, and when you do these, I think it's always a good idea to label what you have. So this is going to be -1, or sorry, that's going to be -3. This is going to be -1, and this is going to be 1. All right, and one of the reasons that I like to label them is, of course, when we think about asymptotes, we know we can't include those in our answers, aka we're going to have to use parentheses. This is a 0. All right, so again, you can go ahead and kind of think this through and what this graph would look like, or we can kind of think about it in terms of plus or minuses. So I'm going to go ahead and kind of rewrite this here so I can see it clearly. I'll rewrite it down here at the bottom. So if we had y is equal to x plus 3 over x minus 1, x plus 1. And the reason that I wrote it in there is because when I'm going to start plugging in these numbers, I don't really care what the output is. I just care if it's going to be a positive or negative. All right, so if I'm thinking about like, actually I'm going to go ahead and replace this with an f just so that we can see what we're plugging in here. So if we have f of x. So again, if I have something like f of -4, I know that I'm going to have a negative on the top. Again, that's going to be -1. I know that. But again, I'm just kind of thinking if it's going to be negative or positive. I'm going to have a negative on the bottom and a negative on the bottom, which is going to be a negative divided by a negative. So this is going to be a negative amount. All right. And then you're going to have to keep going then and plugging some of those in, right? So if we think about like f of -2, well, now on the top, I'm going to have a positive, right? -2 plus 3. And then on the bottom, I'm going to have negative and a negative. So this is going to end up giving me positive, negative. That's going to give me a positive amount. F of 0 is going to be a positive over a negative and a positive. That's going to be a negative amount. And let's do like f of 3. Again, just that positive amount, or what number that we're looking for, positive or negative. We're going to have a positive over a positive over a positive, all positives. And that's how you go ahead and get your number sign on there. But when you're answering this, you want to make sure, of course, that you're not including your asymptotes on it. For example, here with my 0, I know that I'm able to use a bracket because it's including it. So it's 0, but with my asymptotes, I'm going to go ahead and make sure I'm using our parentheses here. All right, so we have, for our answer, is that we're going to go, we're less than, so we're going to go ahead and, I didn't put my other bracket there. We're looking for our negative amount, so we're going to go from -infinity to 3, include 3 because I can be 0. But then I'm also going to go from my asymptotes, so I'm going to go from -1 to 1. And those are going to be all of my negative values there. So trying this last one together here is that, first of all, you want to make sure that you are combining it so that you can see what your function is going to look like. So I know that I'm going to have 4x plus 1 plus 2x minus 12 all over x minus 6 times x plus 1 is greater than or equal to 0. Combine our like terms, so we have 6x minus 11 over x minus 6, x plus 1 greater than or equal to 0. Okay, so I have 0 at x is equal to 11 over 6, and I have asymptotes at x is equal to 6 and x is equal to -1. So drawing my number line pretty quickly here, and we're going to label our -1, 11 over 6, and 6. Okay, so again, plugging in those values to figure out where you're going to have positives and negatives. So less than -1, so something like -2 is going to give you a negative. This is going to give you a positive. This is going to give you a negative. And this is going to give you a positive amount. And again, kind of labeling these. So this is my asymptote, this is my 0, and this is another asymptote, so I know that I'm using parentheses, brackets, and parentheses. So final answer for this one, because again we're looking for greater than, is that we're going to go -1 to 11.6 union from 6 to infinity. All right, so just kind of looking it through, using those sign lines, and figuring out from there what is either going to be greater than or less than 0.